This is part 2 of my series on Introduction to ARM Assembly. I apologize for the cutoff in the previous video, so I just made a disclaimer at the beginning of the video last minute to make up for that. But this is part 2, so in the last tutorial we discussed things like move, add, all those basic operations, and then we also talked about functions and how to call them, and we used the modulo function as an example because that was the multi-step math operation. So tutorial 1 was focused on the mathematical aspect of writing assembly programs. Now this tutorial is going to be less math-centric and more about display. So we're going to be dealing with print statements and scan statements. And if you guys know C, then you know it's called Printf and Scanf. So that's basically the core of today's video, or we're not going to really cover anything else in this tutorial, so I guess that's the whole topic. So enjoy. So you can tell that this tutorial is clearly going to be a lot shorter than tutorial 1. The reason why tutorial 1 was so long was because I had to get you guys started with assembly, what assembly was, and what all these basic operations meant. In this tutorial, we're only gonna cover 2 operations, so that's basically, or 2 main operations, I should say. So that's why this tutorial is going to be a lot shorter. So I hope this is still just as helpful. So we're going to start with the printf statement. Now, what is printf? Well, if you guys come from a high-level language background like C, then you know that printf just prints a statement in the terminal. And we actually haven't gotten to using a terminal yet. That's for a later tutorial in this series. But for now, just go with the code, and then in the tutorial, when the time comes, I will make the tutorial on what goes on in terms of terminal output when we use statements like printf and scanf. So we're going to start with printf, so I'm going to go ahead and write a comment here. So we're going to use printf, and let's give ourselves a task here. Let's go ahead and let's print the statement, and we're going to, I don't want to use hello world because I'm not basic, so let's go ahead and use a very interesting statement here. We are going to say Alfredo pasta is the best dish in the world. Alright? It is. Tell me I'm wrong. So, what we're going to do, just like we did with mod here, see, I also had to introduce you guys to the concept of calling functions in tutorial 1, hence it contributed to the long duration of the video. But now that I already got that part over with, now we can just call functions. So what we're going to do is we are going to say bl printf. Now, this isn't the end of applying printf. We actually have to write some code before. So let me add a new line here. There is something we have to do before actually being able to call printf. So if you guys know C, then you know that the equivalent of this is printf, and then we are going to say, we have the double quote for the string, Alfredo pasta, actually we can just copy this, Alfredo pasta is the best dish in the world, like so. That's your C equivalent, semicolon, for C syntax. Assembly, there's no semicolon, unless you want to write a comment. So actually, like, if you did a semicolon here, it can be a comment like that. You can do a hash, works, and you can even follow C syntax and use 2 slashes. I actually use 2 slashes, but the most basic comment syntax is the @ sign, so for the sake of this tutorial series, I'm going to stick with the @ sign. You can use any of those based on your preference. So how are we going to replicate this printf? So what we're doing is I need to introduce you guys a new operation. So there's more operations needed than just printf and scanf to actually perform these tasks that you would in C with a single line. So one of them is called load or LDR, and that just means load register. I introduced you guys to the concept of a register in the last tutorial. See, that's why long first tutorials help, because I already introduced all the concepts, so now I don't have to explain them. So let me show you guys. So the first thing we're going to need is a label, and a label is what you would write under this section here, .data. Remember, I showed you guys all of this. This is just standard stuff you have to write because it's an assembler program. But underneath .data here is where you can modify this program to your interests. So what I'm going to do is I'm going to add a label here, and a label is, there's not really like a hardcore definition of it, but for the sake of this application, we're using printf. It allows you to it allows you to work with printf in a simple case. So allow me to demonstrate. So we are going to use a label, and let's call it output. Now we put a colon and then space, and what we do, just stick with me here, so dot ASCIZ space, and then double quotes, and then our string. So what does this mean? So output is just the name of a label. We could have called it whatever we wanted. We could have called this a string. We could have called this a pasta string. I don't know. It doesn't matter. We can name it however we like. I just called it output because when we actually get to using the terminal, this will be the output displayed in the terminal. Now, what is this? .ASCIIZ. So if you guys know what ASCII is like this big table of every single character that you can type in a computer. And Z is for, ASCII is actually spelled ASCII, but this one with a Z, Z is for zero terminated. Now, you don't have to know what that means, and I will not get to that in this tutorial. For now, you just have to know that this is what you have to write to actually make this a label. Or in C, it's what we would call a string, or any high-level language for that matter. But with assembly, there is no such thing as a string. There is no such thing as a character or anything like that. Under the hood, it's just integers, and even under the hood of that, it's just a bunch of ones and zeros. So this is our output here. And in the output, what we do is we're going to utilize this, and like I mentioned, one of the operations we need, or instructions, I guess is the more accurate term, is LDR. So LDR. Now, if you guys recall from the last tutorial, when calling a function, see, we did this with mod. When you call a function that takes in arguments, the first argument always has to be in register 0. And then the second argument, if needed, has to go in register 1, third argument, register 2, and fourth argument, register 3. Everything else goes into something called the stack, which is a later concept for a future tutorial in this series. So we need to be able to load this output into the register for the first argument, which is register 0. So LDR R0, then comma, equals, and the name of our label, which is output. And because most of these instructions read right to left, so we're going to load the output into register 0. And in this case, unlike mod, which took 2 parameters, as you can see here, this output, or this printf, sorry, only needs one argument, which is the string. So we have our output here and we defined it here. So we have to load that into register 0. And once we have that as our argument, then we can call printf, and just like that, we can get that printed in the terminal. Okay, so now we're going to talk about scanf. Now, if you guys are familiar with C, then you know that scanf is just a scan statement, or like a scanner, which basically takes user input. So that's what it is. It's the same thing in assembly. So if you come from any high-level language, you have a print statement and you have a scan statement. So scanf is the scan statement in both C and assembly. So what we're going to do is we're going to do the exact same thing that we did with printf. So just like printf, scanf takes an argument, and if you guys remember the rule, you know that just like we did here with printf, the first argument needs to be in register 0. So we are going to load into register 0, and we are going to put input. Now, off camera, I actually created the input label right here. So underneath data, it's input, and then .ASCII Z, and then enter. You can put anything in this string, so enter anything you want. What this is when you execute the program, what this does is the terminal prints enter anything you want, and then it gives a space for the user to input anything they want. So when you're actually working with more complex programs, scanf on its own is not very useful. So if you just call scanf, all it does is it just scans the user input and nothing else. You cannot use it for anything. If you wanted that to be useful, you would have to have other instructions after calling scanf to actually do something regarding the user input that scanf takes. But otherwise, scanf on its own is completely meaningless. So, but in this program, we are just calling scanf without doing anything else because we are just learning it. So once we have the input loaded into register 0, then we can actually call the function, so bl scanf. So with that, it scans anything that it'll first print this enter anything you want, and then it's going to give a space for the user to input. Even if I didn't say enter anything you want, I could have just like done some random gibberish. It still gives a space for the user to enter anything to their freedom. And regardless of what the input is, or actually based on what the input is, in more complex programs, it's going to take that input and go with and be fed into other instructions per se. So that's basically the nature of scanf, or how you would use scanf in a program.